Hello class, I'm going to continue with that section that we were working on, 3.2, measures of variation. And so I think that's on page 74 of your notebook, or 72, can't tell, it looks like it's 72. There's some examples in the page, so I can go ahead and do another example of this just to make sure you understand how to compute the standard deviation and the first sample and the sample variance. Okay, so let's take a look at this. So if we look at the problems, number 3, and again, this is probably following your workbook 71. So it looks like this is page 72. See how it got chopped off there? But I'm pretty sure that's 72, following where we left off. And if we go to the top, it says they want you to find the sample standard deviation for the following data set. Okay, so what you should do is enter your data in L1. Okay, and then after you enter your data in L1, then you're going to do a calculation. So you're going to do stat, you're going to tab to calculate, and you want that one variable stats. Okay, and then there should be I believe a list, and you're going to want to identify L1. Okay, that's where your data is at. You're going to leave this one vacant under the frequency list. We're not doing group frequency, so that you want to leave vacant. And then should go to a calculate. And a couple enters. And then you want to identify the S sub x on your calculator for your standard deviation. Okay. All right. So we do that. Turn the thing on. Okay. Go to stat, edit, hit enter. Go ahead and clear. Go up to the top, clear your data, hit enter, and then start putting in your data, which is 25, 13, 31, 33, 20. Okay, and then you're going to go to stat, tab to calculate, one variable stats. So hit enter. And then under lists, you're going to identify where your data is at. So we did put it in L1. So that's second, and then the number 1. And you want to make sure you leave frequency list vacant. Tab down to calculate, enter, and then you want to look for S sub x, which is your standard deviation. It looks like it's 8.173126697. This would be in units. If you don't have any labeling in this problem, but if you had some kind of units, you would have to label that as units, not units squared, but units. And then your data is entered in data presented as counting numbers. So that means that you want to round one decimal place beyond, round to the 10th place. Okay, so if I do that, this would be 10th place. Then you look at the number to the right. Is this number 5 or more? Yes, it is. It's a 7. So add 1 to that. So we should have S of x is equal to about wiggly lines approximately 8.2 units. And if you look at your choices, it looks like this is a choice, and you can see real light. There's a little dot there, like it's chosen, so it's matching our answer. Okay. All right. Now, let me just see what was the associated formula for that. Let me just go back to your sheet. If I ever need the, because we're using the calculator, but let me just see what we have here for the formulas. I would use this. Let's see. See here, your sample standard deviation. I would, this one is shorter. So this square root of s squared would be fine. Sample standard deviation for a formula. So here's our symbol. And if I put a formula involved here, I could do this up here. S of x equal square root s of x squared would be fine. Okay. This is if you're going to do it by hand, old school. Okay, then I would jot that down. But this is fine. If enough of a form, we've seen this earlier, I think on the first page. So that would be fine. So symbol and formula, and then we get this from the calculator. Okay. And then on the bottom, we'll do one of the variances on the bottom. So remember, nobody's calculator can just give you the variance. What you have to do to check your work for the variance is you're going to square to the second power, square the standard deviation. So for the variance, you basically square the standard deviation. It's basically what you do. Now on the test, you will double check it using that, but then on the test, you will also do the computational model. Okay, and I think I'll put that over here, and I'll say use, it was called the computational model. I think it's called shorthand. Let's see, this sample computational model. Because you're going to have to demonstrate that on the test. Okay, so for that, you'd have s squared, or you could say s of x squared. This is kind of your text, and this is your graphing calculator. So either one is fine. This is an or. And then the formula is, here's your formula, n times summation x squared minus parenthesis summation x close parenthesis there, quantity squared, n times n minus 1. Okay. What you would also have, I think I'm going to put this here, what you would also have on your test, I would have prompts for n. I would have prompts for summation of x. I would have prompts for summation of x squared. Okay. So what summation of x is doing is it's taking 27 plus 12 plus dot 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 all the way to 20. Whereas summation of x squared, it's taking 27 squared plus 12 squared plus, and so on, all the way to this last one, 20 squared. Okay, that's what it will be calculating. Okay, so you're going to enter your data. Again in L1. Okay. Let's go back to stat. Turn the thing on. Stat. Edit, one edit. Go up to the top. Clear. Hit enter. Then put your data in 27, 12, 34, 14, 20. Okay, then you're going to go to stat, calculate. So stat, tab to calculate. One variable stats, hit enter. And your list, tell your calculator where your data is at in L1 and go to calculate, hit enter. Okay, and then you can see here n is 5. So we had 1, 2, 3, 4, 5. And you see here summation of x is 107. And you see here that summation of x squared is 2,625. So that will always be much larger than the summation of x, okay? And then when I plug that into this formula, n, remember, was 5. And then this is the large value. Summation of x squared, that's the large value, 2,625, minus summation of x, which is 107, quantity squared, all over 5 times 5 minus 1. Okay, so then I'm going to do 5 times 2625. So 5 times 2625, 2,625 is 13,125 minus 107 quantity squared. 107 times 107 is 11,449. 5 times 5 minus 1 is 4, so that's divided by 20. So then we have 13,125 minus 11,449. So 1,676 divided by 20. 838, and this would be units squared. 838 units squared. Let's see. It looks like it's this one, but it looks like it has a decimal. Isn't it like a decimal there? Let's see. I don't think we had a decimal. Let's see. 5 minus 1 is 4. It's 20. Oh, okay. I divided by 2. I was supposed to divide by 20. Sorry. So 1,676 divided by 20, not by 2. Okay, now that matches. To be careful. So that gives us 83.8. 83.8. 83.8, and this is unit square. So they don't, in the multiple choice, they don't put their units in there. Unit squared. So if they gave you a length, you would, put your length in there. Okay. Unit squared for that, for variance. Okay. Now when we check it, also we check it on the calculator. We take our S of x and we square it. And when we square it, we should get this. So I'm going to say here, I can say double check on TI 84. So we take our S of x value and we square it. So our S of x value, to go back to stat, calculate one variable stats, and my data is in L1. Okay, so it looks like it's this 9.15. So I'm going to write all that down. There's going to be units quantity squared. So that's why I have this S of x quantity squared. I'm taking S of x and then I'm going to square it. Okay, so then when I do that, I have to type all that in, so just hit 9.154233993. Is that right? I'm going to hit this squared key right here. Okay, and enter. And then that gives us 83.8, and this is units squared. Okay. So yeah, that checks out. All right. Okay, so now let's go to another form of standard deviation and variance, but for frequency group data. Excuse me. Okay, let's see. So in your workbook, let's see in your workbook what we have here. So this is what they're showing you right here is a process for doing this by hand. And you know, we in 3.1 we did group frequency distribution and we did it for a mean, and we did that one by hand because it was a little bit simpler. This one we won't have you do it two ways, by hand and on the calculator. We're just going to show you how to do it on a calculator because you can see this, it's more in depth, these columns here. So you're familiar with the frequency times x of n from x of n for midpoint, but you can see here there's this extra column here where they're doing this extra work here, and it looks like they're doing, can't see that, f times your midpoints, and it looks like they're scoring that. Okay, so and then also look how complicated the formula is. So we're not going to do it by hand. We're going to go and use the calculator instead of doing it by hand. So let's show you how to use it on the calculator. Basically, what happens on the calculator is you enter your data, and then for your midpoints are go in your L1 column, and your frequency list will go in L2. And you just have to make sure when you use your calculator, your list is L1, frequency list is L2, and then you want to stat and calculate that. Okay, so if we look at 74, I think there's an example of that on page 74. Okay, so it says miles run per week, find the sample variance and the sample standard deviation for the frequency distribution of the data in example 2-7. The data represents the number of miles. Okay, so that's our units. So here we'll label miles and then miles squared. So miles for the sample standard deviation and miles squared for the sample variance, okay? And so since we're doing this by hand, we're not going to calculate this because we're not going to do it by hand. We're going to use the calculator. So I'm not going to put that in, but I will say that this is a grouped frequency distribution, and the midpoints go in L1 and the frequency lists go in L2. And then these are class boundaries, not class limits. These are class boundaries. So they just happen N and 5, okay? And, you know, even though we don't have the data, we don't actually have the data, you know, when you round, the rounding rule says you round 1 decimal place beyond how the data is given, but we don't actually have the data. So remember we said when we're calculating the mean for a group frequency distribution, you round according to the class boundaries place value. So these are in the tenths place. So when we find our answers, we would round our answers to tenths place. And it's because it's the same as the class boundaries. Okay. Okay, now the calculator commands would be, you know, again, stats, tab to calculate one variable stats, enter. So tell your calculator your list, you're going to ID your midpoint column. And then you come here to frequency list. And this time you will not leave it empty. This time you want to ID your frequency. So ID your frequency column and call that L sub 2. So that's the second button, then number 2, because that has L2. Okay. And then enter. And then maybe enter again. Let's see. Okay. And then you're going to get a list of data out, and they want, one of the things they want to know is the standard deviation. So that would be the easiest thing to jot down, S of X, and we'll jot that down. And that will be in units, so it will be in miles. So when we're running that down, we'll put miles, okay? And then we're going to round it to the same place value as the class boundaries, which will round to the tenths place, okay? Okay, so if I do that, let's enter the data. Let's go to stat. Edit. Go up to the top and clear. Come over here, go to top and clear. Okay, and under L1, let's put these midpoints, 8, 13, 18, 23, 28, 33, 38. Okay, then tab over here and put your frequencies. 1, 2, 3, 5, 4, 3, 2. Make sure you don't have a mismatch. Make sure all the data is correct. Okay, and you want to go to Stat and then tab to calculate one variable stats. And here it's, you want to stay alert. L1, okay, for your midpoints, and then your frequency list, you don't want to leave that vacant. You want to put L2. So second, number 2. Okay. And then you say calculate. And I'm going to jot down S of X. See, here's your S of X, your variance. So it's 8.287593.772. Okay. And let's see, this one doesn't have anything to check against. Like it doesn't have a little answer key. Okay. But that'd be fine. And then the units is miles. And then we're going to round to the tenths place. Remember we talked about rounding the same value. As your class boundaries. So look at this is tenths, look at the neighbor. Is this 5 or more? Yes, that's an 8. So add 1 to this. So that's going to be 8.3 units. Okay. Now that was remember that's your standard deviation. Okay, so let me go back up to the top now, and we still need the sample variance. So what we'll do is we'll take all this value right here, and then we'll just square that. Okay, so we come up over here. I'm gonna call it S of X squared. I would take this value 8.28793.772 and then square it. So go to just type that in, just come over here and just type that. Also, there's a second quit. If you ever needed to go, you can just type the 8.2, your standard deviation, type all that in, or you can go to second mode. Second mode also clears that. It's 8.287593772. Okay, and I'm going to square that. So hit this here, hit enter. Okay, so that gives me 68.684210. And then if I'm rounding that to nearest tenths, because your class boundaries are in the nearest tenths too, right here. And then look at the number to the right. Is that 5 or more? Yes, it's an 8. So we have approximately 68.7. And then the units miles. And remember it was squared. Okay. All right. Okay. Let me see if there's anything I need to ask or add about that. Let me see. Oh yeah, so yes, there is like for a theoretical part, this is like a problem from your ebook. You see this is a group frequency distribution. So here, none of the midpoints were given, only up to frequency was given. So then you would have to find the midpoints by hand. So in this problem, you do you know how they got the midpoints? You know how they're taking the 5.5 and they're adding the 10.5 and then they're dividing that by 2. So you know that. That's how they're getting 8 for your midpoints, okay? And then so they have you find here, like we're doing the standard deviation, the variance for group frequency data group, and then look what they're asking. Can it be concluded that the lifetime of these brands of batteries are not consistent? Okay, so remember we talked about consistency. That with consistency, you want small values. It was the perfect example was the one related to nuts and bolts, and you need small values, because otherwise, if you have large values, that will throw off, right, the consistency, right, like the bolts will come apart or come off the wheel, that type of thing. So um, if we were to ask you for the consistency, like they're saying, can it be concluded that these are consistent, right? I would say no, only because they're not close to 0. Something consistent hovers around 0. This is 8.3 and that's 68.7. You need something that's literally like, 0 0.0, so something much smaller. So this would be no, at least for this discussion on consistency. Consistency that can it be concluded these are consistent, and you would say no, because we don't have values that are close to 0. So somewhere I want to write that down for this problem. Consistency not present, since standard deviation sample variance are not small, close to 0. Okay. Okay, next we need to talk about something called a CVAR, and the way they'll word that, they won't come out and say use CVAR formula. They'll say something like comment on the variation, and then they'll have the variables. Like here in this example from your ebook, we're going to see the variations are age and income. So talking about accountants, their age, and then their incomes. Okay, so that's an example of that. So at the bottom here, we do have the formula for that. It's another measure of variation. It's called the coefficient of variation. The coefficient of variation, CVAR, is the standard deviation divided by the mean expressed as a percentage. So that's why there's similarities there, okay, to use in the formula. Use the CVAR to compare standard deviations when the units are different. So this is important. When is CVAR utilized? It's when you have units that are different. Okay, so keep that in mind. Okay, and as far as the formula goes here, this is fine. This is the S from your textbook, right? So that's your standard deviation. Remember, this is your mean, X bar. C bars, and then it's a percentage. That's why they do times 100% because it's noted as 100. And sometimes it's 100 and then 100.5 or 100.65. So it has to be rounded at least one decimal place beyond how your data is. Okay, so also in your formula, if you, S is also it's also S of X, standard deviation divided by mean times 100%. Okay, so just know that sometimes they use S from the text and S of X from the graphing calculator, but they're both equivalent. Okay, so let's look at an example on page 75. Okay, sales of automobiles. So the mean of the number of sales of cars over a 3-month period is 87. The standard deviation is 5. The mean of the commissions is 5,225 and the standard deviation is 773. Compare the variation of the two. Okay, so I'm going to use, here's your, it doesn't come out and say use a C-var. The way they'll word it is compare the variations, okay? And so here we're looking at these number of cells, right? And commissions. These people are receiving commissions. So you can say something like CVAR, and then I'm going to put here sales of cars, a little subscript. The other CVAR that we're working with, because we're going to have to do 2 formulas or 2 computations. After we do the sales of the cars, so I'm going to label that as commissions. Okay. And then on the test, you would want to write down the formula. We just saw the formula on the previous page, so I'm going to write it down here. So we have S divided by the mean times 100%. Okay. So here you can use S or you can use S of X. Okay, and when I do my substitutions, the mean over a 3-month period was 87. On the top, your standard deviation looks like it was 5. Okay. So then when I type this in, I just type in 5 divided by 87 times 100. Now, as far as rounding goes, I went ahead from previous works. The thing about this ebook is they're not real good about telling what to round to. Oftentimes teachers have to like look at answer choices to see, just to confirm. The good thing is on Connect Math, they usually are real good about telling you what to round to. So round whatever place value they tell you to. But if I think about the rule of thumb, and I can see how data is presented like as counting numbers or whole numbers, if you will, when you have these means and things that are given, you see, they're like counting numbers. So if I do the same, but this, well, try to do a little bit better. It's like round, we want to round to the tens place. Look at the neighbor to the right, is that 5 or more? No, so we'd have about 5.7% for that. Okay, and then we do the same thing for the commissions. I don't have to write down the formula, I already have it there. Remember on your test, your teacher wants the symbol or the like the abbreviation, and then the formula's there right here. We don't have to write it again. And then this problem we had standard deviation was 773 divided by the mean. The mean is, let's see, mean looks like it's 5,225 times 100%. So if I type that in, 773 divided by 5,225 times 100. $14.79 something. Round to nearest tenths. So this is round to nearest tenths. Look at the neighbor. Is the neighbor 5 or more? So yes, it is. So you have to add 1 to that. So we have about 14.8%. Okay, let's see. Okay. That's fine. I was just checking my answers to a previous page. That's fine. Now, sometimes, in your formula, sometimes the standard deviation isn't given, and instead what might be given is the variance, and that's what's happening on this next problem. Sometimes the variance is given. So I have to make a note of that and tell you that if the variance is given instead of the standard deviation, then you want to use the symbol, the square root of the variance. Okay. And the reason for that kind of is related to, let me go back to our first one of our first pages. Let me see. Actually, I had 2 pages. The first page, and I have one with formulas. Let me go back to the one with formulas. That's this idea here. See, standard deviation, square root of your variance. Okay. All right. That's kind of what this is related to. Okay. And I can do, or I can say like this. Okay. Okay, so for us in this problem, the mean for the number of pages of a sample of women's fitness magazines with a variance of 23, the mean for the number of advertisements of a sample of women's fitness magazines is that value there, 182. Find a variance of 62. Compute the variation. So we're going to use the CVAR when they say that. Compute the variations. Okay. So I'm going to have CVAR. And I'm going to put here number of pages. And then on the formula, I'm going to do square root of S squared divided by mean times 100%. Okay. And that's representing our standard deviation. Sample standard deviation is this. Okay. And that's our variance there. Okay. And so then we would have, let's see, 132 is the sample mean. Variance of 23. Okay. All right. So let's calculate that. So I don't know if you remember how to activate a radical. You want to use the second on the calculator. Okay, and second, and then number, or this x squared, see this x squared, see that? So second x squared, because that has the radical above it. So I have second square root key 23, and then this is important, you have to like tab it out on your calculator. Do this tab out here, see that? It's important. Divide it by 132 times 100. 3.6 33205,699. Okay. And then this is a percentage. Remember, this is important. That's your labeling for here, your units. So here in this case, it's a percentage, so you don't want to forget that. That counts as a rubric point. And then if I round to nearest tens, look at the number to the right. Is this 5 or more? No. So it stays as 6, so about 3.6% for that problem. Okay. That's using that they included a variance. Okay. So then the other formula is CVAR. Looks like it's a number of advertisements. Number of advertisements. And we're using the same formula. Okay, because variance is given here. So let's see. The $182. Sample Women's Fitness Magazines is 182. And that's the mean. That's the mean. That goes on the bottom. And it was a variance of 62. So we do square root of 62. Okay, so we should be able to type that in. So that would be second square root 62. Then remember, this is important, tab this out. Divided by 182 times 100. And I didn't put the division. See how I didn't put the division? Divided by 182. So let me do a second enter. Second enter recopies that. Second enter. Go back here and put the division bar. Okay. Oh, and then look, I need to divide by 182. So I'm going to do a second insert. Okay, that should be good. And we get a 4 point something, so 4.3. And remember, this is a percentage. So if I round this to the nearest percent, round to the nearest tenths, this is not 5 or more. So I couldn't round up. And I'm not asking you to, let's see. Yeah, we're asking you to round to nearest tenths. Yeah, nearest tenths. So 4.3. Is that neighbor 5 or more? No, it's a 2, so that stays the same. So 4.3%. Okay. Okay. And let's see some of the other things. Is there something they're going to ask you about? No, they just say compare the variations of age. So here in this problem from your ebook, you've got these accountants and to like their age and then standard deviation. And then here you have like no compare the variations, okay, of age and income. So it's age and income. So remember we said that it's usually used, remember we said that's usually used when you have different units. Let's see how they worded that. Go back to the previous page 74. Use CVAR to compare standard deviations when the units are different. The units are different. So we've got variations of age and income. Okay. All right. Okay, so I'm gonna go ahead and pause for a second. I'm gonna stop the video here, and that way it can also generate the wording for that, because we did cover, you know, the for a group frequency distribution, we did cover the mean, right? Excuse me, we covered the sample, the standard deviation, and the variance for a group frequency distribution, and then we have the CVARs, okay? And then we had done some extra practice at the beginning, some extra problems for variance and for mean. So I just need to take a little break and then we'll get back started. And we'll pick up with the bottom of page 75 then. This looks like it's the bottom 75, so we'll read through that. Okay.